purpose of this video is for you to be able to calculate percent error. Now there's some abbreviations that I want to go over. This is the abbreviation and what it means. P.E is percent error. VA and V.A or V subscript A is the value accepted, and the VE is a value experimental. Now these are the formulas. It's written. I'm going to write it twice, and you don't need them both. I would just get one. Now the top part, it's VA minus the VE, or value accepted minus value experimental, and that's within parentheses, and you're going to take the absolute value of it. The next thing you're going to do is you divide by the value accepted, and then you multiply by 100. If you don't like the subscripts, you can write it like this. It's essentially the same formula, I just haven't written the subscripts in. Now, to do this, these are the math steps you need. The first thing you would do is you take care of what's up in here. And by that, the first thing you do is you minus the two values. So you'd minus the experimental from the value accepted. It's going to give you a difference. And then you're going to take the absolute value of that difference. The next thing you would do involves the thing on the bottom. You would divide your difference by your value accepted. And finally, you're going to multiply the whole thing by 100. Here's a sample problem that I'm going to do out for you. So a person gets water's density 0.98 grams per milliliter, and the standard value is 1.00 grams per milliliter. What's the percent error? Well, the first thing we're going to do is we're going to write out our info. All right? And our info in this problem is that the value accepted is the 1. Experimental value is the 0.98, and we want to know the percent error. The formula for this is the ones we just went over. It's value accepted minus the value experimental divided by the value accepted times 100. And so, the first thing I'm going to do when I have my formula, I'm going to plug my numbers in. All right? I took this and I put it here and there, and I took this and I put it right there, and then that becomes this. Alright, now the first thing I'm going to do is I'm going to subtract these two values and take the absolute value. 1 minus 0.98 is 0.02, and absolute value would still be 0.02. So this is my equation. Now, the next thing I'm going to do is divide. And that would make it, since I'm dividing by 1, then it's not going to change it. And then I'm going to multiply it. And I'm going to end up with 2%. So that's my percent error. And what does this value mean? I got 2% value, 2% percent error. That means it's pretty accurate data. It's pretty solid, and I don't have a lot of error in the measurements. So that's something we like. Here's another example. This Danish philosopher, he was looking at the periods, and that's how long it takes the moons to go around Jupiter, and they tended to fluctuate. And fluctuate means like change depending on the distance of Jupiter from Earth. The further the distance, the longer the satellites would take, and then the shorter. So in 1676, this is 100 years before our Declaration of Independence, he determined that the speed of light was finite, so it was set. He estimated it to be this amount. Now the current accepted value is this. So what was his estimate? So the first thing I would do is I'm going to find my info. This is the accepted value. This is the experimental value. And this is, I want to know the percent error. So the next thing I'm going to do is find my formula. There it is. And then I'm going to substitute. So what is x? X is my percent error. And what is my VA and my VE? My VA goes here and there, and my VE goes there, and I'm left, well, not left, but I make this, and then I'm going to, the last thing is that. Now, the next step in the math is to subtract this from that and take the absolute value. When I subtract it from that, I'm going to get something like 798,000 kilometers per second. And then the next step is to divide. So I'm going to divide this by this. I'm going to get 0.262 times 100. And the last step is to multiply. And then I'll know my percent error. Now this 27 is not very good, but if you consider this was a long time ago and they had very rudimentary machines, I think it's pretty decent.